In this video, we will explain the titration experiment. Titration is an experiment used to determine the unknown concentration of acid. As the first step, we need to prepare the acid solution. We dissolve a non-mass of acid in a certain volume of water. Now we want to prepare it in this flask. We put it in the balance and weigh a non-mass of acid. Look, we transfer acid into base. We transfer 3.03 grams of solid acid and we add water. Then we dissolve the acid in the water very well. We add 250 centimeter cube of water. Now we fill a burette with the acid solution prepared. We should not fill it up of 0 mark. For example, we fill it to 0.3 mark. Now we transfer a base using a pipette. We transfer 25 centimeter cube of base, which is standard of non and accuracy concentration. We transfer them into Erlenmeyer flask. And we add few drops of phenolphthalein. This phenolphthalein is used as an indicator to tell us when the experiment will finish. As we notice, we withdraw NaOH and transfer it into the Erlenmeyer flask. Few of phenolphthalein is added. The solution is becoming pink now. Now, the starting point on the burette is equal to 0. The experiment is by adding HCl to NaOH until the pink color of phenolphthalein disappears. As the pink color disappears, it becomes an end point. Thus, the reaction has finished. So close the tap. Then we record the first data. We repeat the experiment 3 times for more accuracy. The starting point of the first experiment is 0.1. As the solution is pink, we will continue dropping. The color disappears, so we stop dropping. We reach a final volume of 25.35. We repeat the experiment. The starting point is 0.25. We are adding acid now. Don't forget to shake. The pink color disappears, so we stop this experiment. This time the end volume is 25.55. We also repeat the experiment. We begin with 0.2. We add the acid solution. We shake. We reach the end volume of 25.45. How to calculate the volume now? We subtract the starting volume from the final volume. We subtracted the volumes, and here are the volumes added. For the average of volumes, we make this formula. We add the volumes added in 3 experiments and divide by 3. So 25.25 plus 25.30 plus 25.25 divided by 3 equals to 25.25. To be sure from the titration, the volumes added must not be 0.1 apart. We calculate the average volume that base needs to react with acid. Consider this reaction. Acid reacts with base to give salt and water. Based on stoichiometry, 1 mole of acid reacts with 1 mole of base. What is the amount of base? We have concentration of base 0.1. The mole number equals to concentration times volume. Concentration is 0.1. Volume added is in liters. From centimeter cubes to liters, we divide by 1000. Thus, 25 divided by 1000 equals to 0.025 liters. So we have 0.0025 mole of base and reacts with 0.0025 mole acid. As we have seen, 0.0025 mole acid reacts with 0.0025 mole base. Let's calculate the molar mass of acid. Let's remember what's the molar mass. Molar mass is the mass of 1 mole. And the acid solution is 3.05 gram acid solute in water. Why is the mass of 1 mole of acid solute? It's equal to the molar mass. We can cross. Thus, the mole mass is equal to 22 grams per mole. In this method, we calculate the molar mass of an acid. Therefore, acid and base react with each other in a stoichiometry manner. Thank you.